Hi, I'm Oscar Hotel 2, Foxtrot Hotel Juliet, like you can see here. And I've been working on this amplifier I'm gonna put in my car eventually. It's this kind of 1 kilowatt pallets that takes 50 volts in. I still have to figure out how to get the 50 volts from the car, but it should be quite easy. I have a 1 kilowatt inverter, so maybe a server power supply and something like that. I should have something like that laying around. But now for testing at the club, I'm hooked up the rig to the FT1000 to the amplifier. It's just the simplest wire to take was from the amplifier in here. That amplifier is turned off, so that should be fine. Because I want to test different power levels. Oh yeah, I already tried it with a 10 dB attenuator, and the thing is that this pallet is constructed so that it wants to have 10 watts in. There is a 6 dB attenuator in the input port, and also there is some resistive matching going on in the input of the FETs, so the gain isn't as high as in some of the pallets. So basically this thing with the attenuator, it wants 10 watts in and 1 kilowatt out. So I built a 10 dB attenuator from the resistors with a resistor network from 100 ohm resistors to get it to test it out. I already tested out a little bit, but those things are smoking up. They don't handle the power when you try to push some more in it. I put in some liquid metal into the under the MOSFET, so it's good thermal contact with the copper heatsink. There is no at the moment there is no thermal paste under the copper to the aluminium. The aluminium heatsink, that's something I've been working on for a while now. This project has been on and off for maybe 2 years now. I was in the hack lab and used their machinery to crave out this flat area for it. This heatsink has all these bits in it, so that's why I just planned it straight from for that one area, crowd it straight from that one area. It's not perfect, but it should be good enough. I had searched out the screws for the heatsink. Yeah, made some threads in there, drilled the holes and made some threads in there. I sourced them out, but now I can't find them anywhere, so it has to wait until now. I'm just gonna push it not too hard today. How I set up the radio is I adjusted the power output to max at, I think it was 8 watt or something. I using the the FT8 mode to tune it, just pressing the tune, and this means that I can use the volume button to adjust the power level, and the power output level is set so that the ALC will cut down the power at, well, the radio says it's 10 watts. Here we have, there is 100 watts slug in it, so every stripe is 2.5 watts, so I mean 2 watts, yeah, sorry, 2 watts, so that would be 2, 4, 6, around 7 watts drive power at the full tilt, and I can adjust it down here. So I'm gonna start with giving it in. That's around a watt of power, under 2 watts anyway. How this construction work in this one is that the biased power is actually, the enable pin is actually where you pull down the bias voltage. So that's connected So there is basically the bias circuit, and then there is a diode to the enable pin, and when you ground that one, it kills the bias. So that's like connected right now to the relays, so that it ground the pins when the relay through the relays when there is no power with the relays. I put in a MOSFET here, just a simple MOSFET bias with 10 volts, I mean 12 volts in, and to the, so basically when you connect the other, with a pull up the resistor, and when you just put this one to the ground, it will pull up it will turn on the MOSFET, and then turn on the MOSFETs and give the 12 volts in the output, and will pull up the relays and also enable the bias. So basically, if I took out the bias wire, the amplifier would be biased all the time. I adjusted the bias voltage in the neighborhood of 1 amp. I played around with that one for a while. This is a second-hand board. There was some component missing. The PTC, or was it an NTC resistor, was missing. There should be a surface mount NTC resistor right here. I could actually zoom in a bit. Yeah, there should be, you can't see anything of that. There should be a surface mount, but I couldn't search out any of those. So I put in a normal NTC resistor and just screwed it straight up to the leg of the MOSFET. I don't have any low pass filters at the moment connected to this setup. Everything goes, the power goes into the dummy load in the corner there. It should be able to handle all the power. And also the heatsink is something that I outsourced from some bunk that we get to the club or something. It's basically, I didn't pay anything for it, I just worked a little bit on it. And yeah, even 1/3 of the size would be enough for this amplifier, but you rarely kill anything with too much of cooling. So because I have it, it's like, I'm not space limited. I'm gonna install this in the van and screw it on the wall. So I'm not space limited in the way that I should care about having a little bit too much of a heatsink. No space limit, no weight limit in the matter of the one amplifier. So yeah, also I have to figure out how to put off the fans and everything to it, because passive heatsink, it's not gonna work with passive heatsink. So that's still something I have to work on. But for now, I'm still gonna try this out. We don't have any 50 volt power supplies laying around. The lab power supplies we have is not. Actually, I could turn that one off when I'm talking. There we go. Yeah, the lab power supplies we have that goes up to 50 volts doesn't give up so much current that I have to source out some other power supplies. So that power supply there is the radio's power supply that drives the FT1000, and then I have a couple of other power supply, 12 volts power supply, and the battery. And these power supplies are made so that they ground to the earth. So the minus pin of the power supply is grounded to earth. So that's a problem, because if I take 12 volt out of that and put it to this power supply's minus pole, it will ground through the power in the network, and you get a short circuit. So that's why I'm using a what is it called? suojaerotus monte, is it in Finnish? Well, basically it just couples out the power, make it a different circuit, and that's a safe way to do it. So of course we need to have two of those. This is also a variac. I can't get my head around what is it called, but basically it's just a transformer through up to a one-to-one transformer that just makes it a safe circuit for everything, that, or safer circuit if you know what you're doing. So that's 12 volts there, 12 volts, and I think I adjusted this down to 10 volts, and then a lead acid battery that's fully charged. I just charge it fully, and that should make it to around 50 volts. And yeah, I'm not gonna push it too hard today because I don't have any thermopaste. Yeah, and also the 12 volt for the MOSFET, I haven't soldered in any input wires for the 12 volt rail yet, so that's something that I still need to do. So without further, I'm just gonna hook up everything and give it out any smoke. I did get something around a few hundred watts from it earlier, but then I didn't have all the power supplies. I think I was running only with 35 volts or something. And how the bias circuit works is that it takes 12 volts, it has a 12 volt regulator, but everything goes through this massive resistor for the bias circuit, and that's not just with 35 volts, it's just not enough to drive on the bias circuit. So it's actually quite a smart way to do it, but it is what it is when you don't have enough voltage. So let me hook this thing up and I'll be back soon. Okay, the last check, the power is on. We have a current meter there. Everything is hooked up. Press the tune button, we get, around a 1 watt input, and everything seems to work. Let's turn off the transmit, and when I touch this one in, the relays are pulled, we get around an amp of current. Let's make it permanent. So like that, around 1 amp. Here goes nothing. Yeah, we're getting over 100 watts and 7 something amps input. Let me change the slug. Now we have a wrong slug in there. This is 2.5 kilowatt slug. So now we're reading the top scale. Tune. We're getting around what is that? Let me figure out. Yeah, we're getting around 100 watts out. Yeah, it's the top of scale. Around 100 watts out with 7 amps of drive. Yeah. Let's push it just a little bit harder. Just a bit harder. And how is our temps? Yeah, the thing is getting warm. the bias is still around an amp. We're getting around 2,500 watts, 250 watts. Yeah. A little bit more actually. I'm just looking at the bias. 12 amps. Yep. So it seems to work. Let's take off the bias. And then we can check with these settings that how much power we are actually driving with. Let me change the slug. This was something we don't need. Oh, come on. There we go. Yeah, we're driving in around 2 watts. I'm getting 250 watts out about. So a little bit more than 2 watts in and 250 watts out would be in the neighborhood of 10 dB, a little bit more. So that's doing its job. So we can say the amplifier is working. I think I'm gonna try out and put up a bit more drive and just give it a small burst of maybe 500 watts. So now we're reading again the lower scale, yeah. Okay, here we go. That's something around 7 or 8 watts in. 500 watts out. What I think happens is 16 amps in. What I think happens is that I'm losing voltage from the battery. Could actually put in another meter there. Here we go, we have 50 volts. And when I turn on the amplifier, yeah, it still stays on. Let's put it on. And let's transmit a little bit. 46 volts. And yeah, we're reading the top scale. So that would be 500 watts, right? Yeah. So we can compensate for the power loss in the battery and also the wires. Yeah, we're dropping down to 40 volts. That's what happens also with the bias. Oh, that power supply over there is not working as it should. And where does my problem lie? Oh. That's 12 volts. Back up at... Yeah, that drops down 10 volts when transmitting. It doesn't like the... It might actually be the transformer in line, because this one says overload. Let's do a simple reboot. Still in the BIOS, yeah. Turn. Yeah, the power drops down when you try to push it harder. So let me do this. Yeah. We run out of the batteries of these meters. I could lower the voltage in this one. What's going on? Here we go. High up that one. The battery is dead in that meter. That's 10 volts, and yeah, we're just killing up that power supply over there. It turns off. It's not good for the power supply. It actually sees negative voltage in the terminals when that happens. Shit. Well, the amplifier works when I get the power supply sorted out. It's not getting too hot or anything. So far I get out around 500 watts. So I would say this is a success. So I need just an 50 volt power supply and then do this test again and so on.